Good afternoon. My name is Prakash Sinha. I work for Radware. Radware is a little over $200 million company based out of U.S. headquarters is in New Jersey, and world headquarters is in Tel Aviv, Israel. And my name is Prakash Sinha. I've been in software, networking. I've run pretty much everything: product management, architecture, engineering for 22 years. About 14 or so years in product management for middleware. So NetWeaver-like products, middlewares, and past 12 years in networking. And in networking, specifically focusing on delivery of applications, accelerating. How to accelerate, how to make highly available these applications that are accessed over the web. So today's session is targeted specifically towards SAP, both virtualized and cloud-based deployments. And I'm going to talk in this particular session. There are 4 key areas that we're going to cover. So one is how to make your SAP instances highly available, whether they're on-prem deployed or they're in the cloud or a mix of cloud-based deployment and on-prem deployment. So how do you make that highly available? Because many times these SAP instances and systems and applications that are delivered over that are mission critical. So that's one core area. The other one is, as we move towards web-based delivery of these applications, how do you make sure that when users actually access these applications, they're less latent, meaning it doesn't take as much time. And I've used SAP's deployed systems in many different companies. And there's some gripe from users about when access is in question. So how do you reduce access times and latency? The third area is how do you monitor performance for this, and how do you deploy systems that can accelerate these device access, right? So that's an area that we'll cover. And most importantly, the security aspects of it. Right? So as you open up your systems, your portals towards partners, towards mobile access, for example, how do you make it more secure? And that's an area that Radware has a lot of experience. We have a lot of experience in very large systems, especially in terms of systems that are used for stock exchanges, for banking, for military systems, for example. Right? So we've done this quite a lot of times in very large scale. So we'll cover some of those in this session. Before we actually go there, I just wanted to quickly talk about what are the application trends and how does SAP deployed systems follow these trends as well, right? So if you look at, for the past couple of years, you've heard of VMware, of course. Virtualization is a big initiative. So, a few questions here before I, start into the session. How many of you are virtualizing your applications today? How many of you have plans for it? Any cloud-based applications? Any plans of moving to a cloud? Yes, a couple. And then how many of you are working on the application side? How many on the network side? How many on the administration? Okay, so basically the idea, the way I organize this presentation is going to merge everything, like how are applications deployed, what are the virtualization challenges, cloud, and then how do you accelerate, right? So basically those are the areas I'm going to cover. So if you look at applications that are being delivered today, earlier there were lots of data centers closer to the users. And as virtualization is taking hold, and the key area is drive down my cost, and for cloud-based systems, it's make it more flexible. Flexibility is more flexibility and extensibility is a key driver there. So virtualization is a step towards cloud, and as that happens, you see these data centers being consolidated. So consolidation of the data center has a lot of impact, right, to users. So if you look at the usage of how users access these systems, they're accessing them more and more remotely. There are branch offices, large companies may have lots of branches, and so when these users access these applications, there is typically wide area network deployed, right, or involved in access of these systems. So when you access these systems, especially for web-based systems, you have web protocols, HTTP in particular, not very efficient. It was not designed for this kind of access really. It was, collaboration, but not really business systems, not designed for business systems. There are new techniques that are coming. Speedy Gateway is one example of that, which are designed to accelerate some of this, and WebSockets is an example of enhancements to HTTP to accelerate and optimize this delivery, but not there yet. And very shortly, browsers will process speedy transactions as well. But we're not there yet, and SAP definitely is not there yet, right? So web protocols not being efficient, users being remote, and the third key, which is, one of the most important things, and you see this every day now, is about security. So all of these web-based systems are being accessed over mobile devices, through desktops, through iPads. There is a huge amount of security requirements. And in particular, if there are partners involved, then there's APIs, right? So application programming interface that are being accessed to use these systems, that opens up a lot of holes into denial of service attacks and web service and XML-based attacks. So we'll talk about those. So how does SAP follow this? Very, very similar, right? So server consolidation, virtualization of applications, consolidation of data centers. Result, exactly the same thing, WAN application. And I've used these systems too, right? So I use these systems today, right? So response times are the most critical. As an end user, for me, response time is the most critical thing. I mean, if I can't get my slides or pricing or training material in time, or even my spreadsheets in time, then there is a problem, right? I need that information right now. Business intelligence, analytics, all of these are accessed over these systems. And then the second piece is the move from SAP GUI to the web GUI. So that's the other aspect, moving towards web-enabled applications. That's all the things that we talked about previously applies here as well, right? So in this, latency, because HTTP not being very efficient, introduces a lot of latency challenges to delivery. So let's look at a typical deployment, right? So this is a typical deployment. You have application servers in the data center or in the cloud, or virtualized blades, for example. You have messaging services. You have some dispatch services, some routing services, and then you have local users inside the firewall, and then you have branch users, you have partners accessing these systems. Typical, right? So what are the key? So WAN issues impacting delivery to branches and to remote users. Single point of failures. So that's because these are mission critical applications that are delivering, for oil and natural gas, for banking, for CRM. They're all mission critical applications. My pipeline information, all of those are being delivered through SAP, different various modules, right? So how do I make sure that when one system or one instance in a virtualized delivery goes down, I can still route my users, my clients, to a new instance without denying a transaction from the user, right? So that's the key, right? How do you disaster proof and make this highly available? That's the area of concern. And then, as you open up these systems, the APIs, the access, how do I make sure that I can handle a distributed denial of service attack? Many different users trying to access an API and trying to hack my system. So let's look at it from, so one is a deployment perspective. You look at it from a developer perspective, right? How do you compose a service-oriented architecture or composite application? So this is an example of a composite application that could be a REST interface, or it could be a WSDL, for example, web service description language, that's used to access some of these external services, right? So I'm trying to access or create some credit information. I need a FICO score. I go to FICO site to actually get information. And typically, I'm deploying some application in NetWeaver, right? So that's a typical composite application. It's architected as a service, being delivered as a service over the web, right? It's composed of many different services that are composite and running on some application server. That could be a cluster, right? So these external interfaces are the ones that we are really concerned about of what, because each point of those services are mission critical for somebody, right? Or some application. So what's the issue here? So first is when you're accessing these systems, these could be in service orientation, they could be SOAP application, they could be using HTTP, a RESTful use of those applications, right? So using HTTP, they're not very efficient. The second piece is security threats. You just open this API to external world, there's an issue of threat. Then the third piece here is access enforcement. Who is accessing my systems? How do I know that they're authorized? First, they are allowed, they're authentic, and then second is their authorized access to that particular application or service, right? So, and of course, reliable and available is always a challenge in this scenario, right? How do I make sure, even if this business app is virtualized, how do I make sure that the instances are available? Right, so let's take a look at, what are the techniques that are used in the networking. And by networking, I don't mean just a box that actually sits in the network. A networking device could also be virtual, meaning it's delivered as a VM that runs co-located with a virtual machine that's running your application, right? It could be running on the same system, it could be running on a different system, right? But they could both be virtual. They could also be delivered as a service on the web, right? So for example, you go to Amazon, you have, your systems, your applications are in your enterprise, and for, extended or, peak usage, you rent some capacity on Amazon and you upload your application there. How do you make sure when users come in, they can be routed to either one depending on what the time is or what kind of capacity you have at that time, right? So those are kind of things that are addressed by using application delivery controllers. So let's take a look at what is an application delivery controller. So application delivery controllers are typically called reverse proxy devices. They sit in this reverse proxy configuration with backend data center services, applications. So if you look at to the right, they're all different types of business services that may be running on your application servers in the enterprise. They could be running in the cloud. The access to these users, so when users are trying to access some application in the data center, they're typically being proxied by an application delivery controller, meaning just like in service orientation, they're decoupled. Right? That's the whole idea behind this, right? The idea is to decouple users from, or providers from consumers, right? So here's a consumer. The consumer gets terminated. In the networking world, the termination means that client connection is being stopped at that point, right? On the other side of an application delivery controller, you pool connections. In computer science, one of the most expensive operations is file open. File open is, every time you do a file open or do a handshake, that's a very, very compute intensive operation. It takes a long time, right? That's why typically first transactions are the most expensive transactions. So what these ADCs do is they typically hold these connections to the backend application servers, middle tiers, databases open for long periods of time. They keep them alive, right? And they reuse those connections over many, many clients. The technique is called multiplexing. So you multiplex client connections over a pooled set of connections. Now, as soon as you reduce the number of connections on the backend side, you don't need as many services, right? Because you're reusing those services. So ROI actually comes from reducing, these type of operations that you would typically do on the application server. So that's, in a nutshell, that's what application delivery controllers do. And the key areas that they address is availability. You can have many instances of app servers maybe in the enterprise, maybe in the cloud. The job of the ADC is to route it appropriately, route a request that comes in appropriately to wherever that application may reside, and whichever has capacity to actually process that request. So that's availability is one of the uses. Acceleration is now it's sitting in front of those backend services, right? So the job of the ADC in this context is if the user request doesn't need to go to the application server, don't send it there. So there are some techniques that are used to do that, right? Caching and compression are some of the key issues, or the areas or functional areas that are addressed by ADC. Performance is, impacted or reduced by, using compression. There are some, techniques that are used to reduce the amount of data that's sent back to the consumer, right? So by using that, you can actually improve the performance, and we'll go into more detail. And the last aspect is security. So one of the key areas that these ADCs work is they enforce access. So they are access enforcement point in the network, meaning we're going to any of the applications, since they're acting as a reverse proxy configuration, they actually stop that connection, take a user identity, and then can use your backend identity management systems. Could be an LDAP, could be a SiteMinder, could be Active Directory, any of the backend systems, and they can take the user identity that's provided and validate that identity before that request can actually go back to the end user. So they use some of these techniques in addition to what an application would do. Application typically authorizes, right? And ADC authenticates. So the authentication is done on the ADC, the authorization is done on the application side, right? So, and in addition to just being the access enforcement point, they actually also act as, using some techniques on the TCP, can prevent denial of service attacks on the backend applications that's being proxied, right? So in terms of deployment, both the application and the ADC can be virtual, right? They can be co-located, they can be on-prem, they can be hardware-based systems or network profile, or they could be hybrid, right? You can have a mix and match of these, right? So we didn't have enough time in this session to actually talk about hybrid deployments and the various type of configurations. So I kept it just to limited set of how are ADCs available today, right? So now to the meat of this session, right? So how do you use some of these ADCs now that you have a view of what ADCs are, and how do you use that to accelerate SAP applications, right? So there are two main ways. When we talked about the session information, availability, performance, latency, and security, they can be delivered two ways. So in the previous slide, we see this ADCs deployed in front of web servers or app servers, so middle tier or the data tier. They're deployed in two configurations. One is symmetric, and the other one is asymmetric. So this configuration is asymmetric. Asymmetric meaning when you use this kind of configuration, you don't need a footprint on the client side for ADCs to work, or ADCs features and functions to work. That's asymmetric. The other one is a symmetric. That's also called LAN optimization. The other one is a WAN optimization, where you typically have a client footprint that can be used to provide some proprietary acceleration technologies or techniques between the ADC and the client footprint. Right? So they are called symmetric, dual-ended, or WAN optimization technologies. So we'll look at both of those. So the four areas, high availability, latency, security, and addressing some of these WAN latency. So how are these deployed? So we looked at SAP deployment infrastructure earlier. How does ADC deploy in that context? So ADCs deploy in front of these SAP application servers, right? So, and the whole idea is to provide this availability to and provide redirection of user request to SAP application servers, and if one of the instances of application server is down, even though they may be clustered, there might be services that may be down. You don't want to deny a transaction from the user till you can retry and retry to other instances. And the way you do that is using health monitoring and some of the traffic redirection techniques. These are some of the algorithms that are available on the ADC, very easy to pick and choose what you want to do when something like that happens. How do you want to enable health monitoring? The other area is in terms of application security and compliance. So this is where you want to make sure that sensitive information is not leaving the enterprise, or a malicious type of request is actually not going. And in order to do that, for example, for financial transactions, you want to provide a PCI report, for example, or in case of healthcare, a HIPAA compliance report, right? So those are some of the reports that can be enabled because this is a single point of entry into your enterprise or into your cloud-based deployment, right? Then, of course, utilization. So the key areas that ADC work is the value of the ADCs actually come from offload, right? So the ROI is how much mundane transaction services that you can offload off of SAP servers so that the SAP server instances are doing more of the business processing. So you don't want to do SSL transaction processing, a TCP IP processing, all of the things that are not really adding value to your transaction, business transaction, right? So those are offloaded from servers, back-end data center servers, so that you can use more of that capacity for your business usage. That's where ADCs offer value. That's how the ADCs offer value. And of course, latency reduction is one of the key areas. So let's look at more in detail of how do you do high availability using these services. So this is there are two data centers in this instance, multiple instances of application servers, SAP application servers, NetWeavers, for example. And there are users for both from branch, from remote access, and also local users of these offices, right? So you have ADCs deployed in front of these servers, and there are a couple of ways that you can actually make sure that users are automatically redirected. So the first use case is of local server load balancing. It's called local because ADCs are local to that data center. Okay, so it's called server load balancing in general, SLB, or local server load balancing. Because you're load balancing to instances of application servers within that particular data center. That's why it's SLB. And the way you actually do that is by providing, by routing user request to a particular instance based on variety of information, right? It could be based on capacity, it could be based on load, it could be based on number of transactions being processed. It depends on you, the IT administrator, or depending on what kind of system that is, right? So based on those criteria, you can route user request, or you can just want to do a round robin, right? The first one goes to the first instance, the second one goes to the second, and so on, right? And you can round robin that. So there are a variety of these configuration options, click and choose pretty much, available on these devices to actually do a local server load balancing. That's one way of providing availability, right? So the second is, what if you're connected to an ISP and that connectivity to the ISP goes down, right? So typically what you want to do in those kind of instances is, you want to route your users to another data center which is connected using another ISP, right? So basically that's where link load balancing comes in. It's called LLB, or link load balancing, where you would route user request, and if that ISP is down, then you would actually route that user to the other ADC to process application in a different way, right, from a different data center. So that's link load balancing. This is another way of providing disaster recovery, right? And the third one that I didn't show here is the global server load balancing, which is, even between the data centers. So if a user is coming in, typically you would route that user request to the data center closest to that particular user. But if that data center is down for whatever reason, you might actually want to use either local load balancing, or use the LLB functionality to provide a global server load balancing, which is what, routing that user to the other data center, right, based on ISP availability, right? So you can use that for just redirection, or you can use that as a global server load balancing mechanism as well. So that's the first, how do you make those instances available, right? The second is, how do you reduce the latency to the user, right? So reducing the latency of the user can be done in many ways. I talked about one, which was, since these ADCs sit in this reverse proxy configuration and routing those requests to the backend applications, you can use some of these TCP multiplexing techniques to reduce the amount of connections that you manage, right? That's one way of reducing latency to the user, because the network time is reduced because you're not doing that file open, okay? You're reusing that. The same thing goes for handshake, for SSL. It's an SSL-based transaction. You're not doing the SSL transaction, right? So therefore, it reduces the amount of latency that user gets. The other aspect is caching and compression. So let's say I'm a branch user. I'm trying to access a document. And that document will be accessed probably by other users in the branch as well, right? So the ADCs use this caching technology to actually cache that information the first time it's available, and then use a cache hit if another user tries to access that information. So the transaction request from the second user doesn't go all the way to the server, right? So not only are you reducing the load on the server, but you're also reducing the latency for the user, because that user never, the network time for that user is much shorter because of this document being served from the cache, right? So that's the other way of using caching to reduce latency. The third is compression. The data compression is the amount of data that's transferred over the web, right? So especially over WAN, the WAN links, right? So WAN links are not infinite in size, right? So, and you pay for that. So, latency reduction also involves compressing that data that you transfer back and forth. And many applications, SAP applications and SharePoint and a couple of other applications send this data back and forth, all right? So there are some techniques in SAP as well that allow you to reduce the amount of data that's being transferred over this WAN link. Then, of course, there are TCP, window size, and there are many other techniques in TCP itself that these ADCs employ congestion, to reduce congestion, to reduce misses, right, on the network, right? So by adjusting window size, by adjusting the amount of data that's being transferred. So you can optimize by, sending as few requests as possible with as big a large a message size as possible, right? So there is an optimization between that these ADCs employ. Then, of course, SSL offload is one of the big use cases in this scenario of reducing latency. So SSL handshake all the way from client to the server is expensive operation, right? So SSL offload, instead of actually performing SSL transaction directly on the SAP instances or SAP servers, you offload that to the ADC that's in front of these SAP servers. So the traffic between the ADC and the SAP instance within that particular data center is in the clear, so that you're not incurring the overhead, right, of this compute operation. And you're reusing that on the ADC. So that's one of the ways of offloading, technical processing from SAP, and leaving those SAP instances for business processing, and then Many of these ADCs have specialized chips for SSL processing as well, so they do it much faster. They can also work on 2K certs, right? So that's a new mandate that came in from NIST last year, and it would be, I think we're mandated to implement it by 2014, if I'm not mistaken. So 2014. In between that time, you can you keep using your 1024-bit certs. But beginning 2014, you have to use a 2K cert for any of the external application, external-facing application. So not only 2K certs are much more difficult to process, they are almost 4 times more expensive to process, right? So the number of key bits are increasing, right? So because of that, you need 3x more capacity to process the same number of transactions. So that's something to keep in mind for future. As if you're doing your SSL processing on your SAP today, keep that in mind that the 2K cert mandates are coming, and that will impact the instances that you deploy and configure and plan for capacity today, right? So think about that. So anyway, so this is there are lots of companies that actually work with many of these networking companies. I was one of the first ones in 2006 when SAP started working with networking companies. We actually initiated some of these networking in SAP COIL labs, which is co-innovation labs, right? So all these networking companies together created some of these different standards and techniques for SAP instances and SAP applications to work with these networking devices. So look for validation by SAP. There is a great site on SAP. So co-innovation labs, search for co-innovation lab if you're evaluating companies. That's one good way to get more information on what SAP is doing with networking companies as well. Now, one of the areas that we also talked about was how do you secure these applications, right? So there are lots of different ways of attacking these applications as you web enable them, right? The first one is, what if I don't, let external users know that it is an SAP application, right? The technique is called obfuscation or hiding, right? So you hide implementation details from external users. So so typically, because ADCs are deployed as a reverse proxy, the client really doesn't know who it's talking to, right? They're decoupled, right? And decoupled for a reason, so that you can scale them, you can make them available, but you can also obscure them, right? So when user request comes in, and there are many of the ADCs provide this capability of being able to map inbound to outbound request, right? So this is a way of obfuscation. That's a very, very easy way of providing denial of service protection because they're named differently, right? The other one is, attack mitigation in terms of TCP level, programming, right? So this is where you do a denial of service protection by, there is a 3-step acknowledgement process in TCP handshake, right? So typically what happens is most of the application servers allocate memory on the application servers as soon as you get an ACK from a client, right? So syn ACK is when memory is allocated typically, right? There is a late binding way of connecting. So when a user request comes in, you have memory allocated, and typically what happens in denial of service attacks is lots of requests for a site is made. When the ACK comes in from a client, memory is allocated in the server, and the client actually keeps that connection open, right? Never fulfills that request, right? So basically, the computer on the server side runs out of memory. That's how these results work, or the attacks work, right? So and you can do that from many different points. Therefore, it becomes distributed, right? So one of the ways of preventing something like that is by late binding, not allocating memory on first use, right? So that's most of the ADCs actually typically deploy that, employ some of that technique. But there are additional things that you can do in terms of behavior analysis, there's a response team, there's an IPS, intrusion protection systems, or based on a reputation. So typically there are external services that can be checked against for a reputation of a particular user. Right? So there are reputation-based systems that can be employed to prevent these distributed denial of service attacks. The other one is applications, specifically in terms of SAP. Their OWASP, this is the top 10. OWASP actually is a user forum that actually provides top security threats for applications, and they change it every year, right? So the top 10 threats are specifically all geared towards applications, right? So make sure that any protections that you acquire for preventing security breach for these applications address this OWASP top 10. They're the top of mind, most employed attacks against applications, right? And then of course prevention of data theft. So you can secure the pipe, but you can also use some data leak prevention type of systems to prevent data leakage, classified data. There is a lot of use of those kind of systems as well. So web application security, both for the pipe that's used to deliver information, and as well, not just pipe, but also the data that actually flows over inside that is also protected. So DLP type of systems as well can be. And then of course, many of these systems are XML based. So there could be session hijacking. All the things that you could do at HTTP layer, you can also do similar things at XML layer, right? So basically HTTP and XML, even though XML is actually carried inside of HTTP as a request body, they can also create recursion attacks inside of this XML document itself. And that document is typically processed on the server. Okay, so you want to make sure that before that data actually goes all the way to the server or reaches the server, it's actually scrubbed, right, by some security techniques, right? So there are lots of, many of the ADCs have modules that actually scrub the data before it actually reaches the server, so that your server is not impacted by any maliciousness. It's like SQL injection, LDAP injection type of attacks, cross-site request forgery. So there are a long list of attacks that can be deployed against the server. So use some of these areas to figure out which type of application security mechanisms you'll employ to secure the SAP application. It's very, very critical that actually it's in front of your SAP applications, because the application themselves should not go down. Then of course, if you look at in terms of WAN latency, I talked about the symmetric acceleration, right? So far we've talked about asymmetric acceleration, where you didn't require anything on the client side. Now there is a symmetric way of accelerating which gives you tremendous results, right? So typically in this, what we've done is we work, typically ADC companies work closely with SAP. SAP has this technique called ACAD. Right, so this is an application delivery technique that applies specifically to SAP between the SAP and the usage on the SAP GUI or web GUI. Right, so they have this proprietary protocol and a proprietary way of compressing that information. Typically, when you deploy off-the-shelf WAN optimization technologies, they don't accelerate it because this back and forth between the client and the server is proprietary, right? So it doesn't gain from any WAN optimization techniques. So look for SAP ACAD technology and validation by SAP. Coil Labs is a good place for doing that. Now, how does these technologies work? So typically you have a central ADC, because you have to keep in mind of you're taking virtualization initiative, you're taking cloud initiative. Orchestration is a very, very important factor in that, management and orchestration, right? So two key impacts in terms of virtualization. You want to bring your application up and down based on usage. You don't want manual intervention to bring these instances up and down, right? So that's why orchestration is so key. So what these do is, a central ADC is typically pushing some information to the branch offices. And this is nothing but a SAP ACAD module integration that typically sits on the SAP branch office side. And that's how the compression is achieved between the SAP ACAD central ADC. And that's why it's called a WAN optimization technique, right? It's a dual-ended solution, right? There's something in the branch, typically running as a VM on VMware server or some other hypervisor of your choice. And you accelerate this. This is secure tunnel between the central ADC and the branch. This is local, so there is unsecure, clear traffic. And on the backend data center itself, there is a clear traffic. So this clear traffic on the backend side between application server and the central ADC. There's encrypted and secure traffic between the central ADC and the branch footprint. And then you have clear traffic. So you're not doing the, expensive compute-intensive operation on the branch devices or the SAP network, servers, right? And still secure because it's inside your data center itself, right? So that's where you gain from these techniques. And this tunnel is secure, but it's also applying some performance improvements, WAN optimization technologies between the SAP GUI and the backend SAP instance, right? So that's how you gain from applying this WAN optimization techniques to this. So, in a nutshell, how do where is it saving time? So if you look at the time between the user and the SAP application, there is a client wait processing time, there is server time, there's some network time, and there's client rendering time. Right? So typically what you're saving here is the processing time that's on the server as well as some of the network time that's required here using some integrated caching, some compression mechanism. So using some TCP optimization as well as still providing the end-to-end security, right? So that's where you gain from these. So when you deploy some of these ADCs, what are you looking for, right? So we looked at what do these ADCs do? What are the ways that they address some of the limitations? So what to look for when you deploy them, right? So configuration templates, definitely, because you're not networking users, right? You shouldn't have to learn a whole new way of doing things, right? So a configuration template that allows you to work exactly the same way you work with SAP instances when you launch an SAP new instance of an SAP application, for example. Then also, one of the things that I briefly touched upon was orchestration, right? When you bring new instances of SAP, you should be able to bring new instances of ADC along with it, right? Just like you bring. And then, of course, compliance, logging, who's connecting to what, etc., right? And then per specific application flow, you can use an SAP application for many different users. You can carve out that SAP instance for application flows as well, right? Different departments using that in different ways, right? So you should be able to customize this ADC per usage of this application. So ASLR integration is one of the ways that you provide this integration into orchestration. So there's a configuration manager typically in these ADC devices that checks with messaging server if new instances are up. If their new instances are up, then it actually goes in and uses an application template to push that new SAP instance information into the ADC, and all of a sudden now new user requests that are coming in can be routed. So you can update by this configuration what are the new instances, what kind of new load balancing policies to apply to this, whether they're local or they're global, and then you can update that configuration. So this is on-demand change of how new instances are brought up and routed to, right? And you can do the reverse as well, right? So basically you upload, so this allows for very rapid rollout. So one of the things to look for when you do this is it should allow you to do this in a way that you're used to with your existing tools, right? So very, very quick, demo on what kind of benefits that you see. And just if, in the interest of time, I'll just skip to one, which is, so there I had two demos. One was, and they don't have sound. So I'll just do, okay, I'm going to pause it here. And unfortunately, actually, it's, I wanted to do a side-by-side comparison of access using direct and access via an ADC. What this is showing you is access to a login page for training via SAP. So this is the LSO overview that you would go to download documents, and your company may have their own learning solutions, etc. And this is, one is login with a dual-ended solution. And the second one is downloading a particular document from that site to do some training, right? So here's an example of how quickly these kind of solutions. So this is access, the first login. So this first login page, and this is through the browser, right? So I'm capturing information about how much time this particular page load takes, right? So this is like 0.6 seconds. Right? The same thing in direct access, exactly the same identical thing, is about 10x, right? No changes other than just the dual-ended solution in place. That is, no changes to application at all, right? So 15.4 seconds for exactly the same thing. The load time for portal page is about 28 seconds or so, right, in the direct access. So you get, whenever you deploy some of these technologies, you get 10x, up to 10x, or maybe more, depending on if you have document downloads. It's even more than 10x, right? So it's still not complete. Still going on. I think it's like 28 seconds or so, 28.2 seconds. So that's just with just a login. And just to show you an example of a similar thing of clicking on one of the learning solution. Pause this. So this is the same thing, but now I'm actually going to a content, right? So a particular content. In this same view, I'm clicking on a content, and I'm choosing a course. 4.8 seconds to the LSO main page, and it's about 16.9 seconds on direct access. Total render time, about 4.9 seconds on the first load of a document. And no difference between these two other than just being the ADC in the mix. Still going on. Significant. So there are many companies that actually do deploy them, but I just wanted to bring this as an example. So this technology applies not just to learning solutions, but any kind of acceleration or access that you have with SAP GUI or Web GUI, and there are lots of other benefits that you would actually get from these. Right, so very, very quick case study. So I went through these demos. So this is an example of one of the gold partners for SAP, one of the largest SI consulting partners of SAP as well, based out of India. And they deployed this in-house. They have 22,000 users that are accessing these systems. Biggest challenge was slow load times. They do training all over the world, right? And they have seen 80% improvement in load times almost 99.99% availability with their GSLB. So huge benefits, and it's a very simple solution. It's not, it's not rocket science really. It's, something that's proven, it's replicable, and so this is something to. I just wanted to bring this out, that this is one of the largest users of SAP that's actually deploying it in-house. So lots of good, examples where you can go get more information. I would definitely suggest go to Coil Labs. So this is the Palo Alto Labs of SAP to actually look at these. And just to summarize very quickly, all the things that we talked about. We covered a lot of material, but key things are: there's a consolidation in play. Virtualization is one of the drivers for it. Cloud-based deployment is another. As you open these access to these systems to web-enabled applications, there's lots of things to consider: latency, availability, security, and performance, right? And especially because these SAP systems are mission critical, right? So there are two ways of doing this: asymmetric acceleration and symmetric acceleration. So we talked about both. One is LAN optimization, the other one is WAN optimization. And there's a mix of those two. Typically, when you look at in the first part, we actually looked at the asymmetric deployment, which does offload and addresses the security, availability, etc. In the symmetric acceleration, when we looked at it, it integrates with SAP ACAD modules to provide acceleration for access using Web GUI and SAP GUI. Right? So make sure that your ADC, whatever you choose, technologies that you choose, works with your directions in cloud computing and virtualization and the tools that you've chosen. That's the most expensive part of it, right? Because that's where you're going to make the investment of people, getting access, the training tools, etc., right? How they work with these systems. So make sure that they actually work with the same systems that you are used to working. And then, of course, make sure that they're certified by SAP. So with that, I'm going to leave it open for questions. Any questions? I'll be around, or you have my contact. So, if you want to know more, if you want to look at some of the results, or look at, your peers in your industry, if they're doing something similar, let me know. We'll be very happy to address it. Hope the session was useful as well, and appreciate your session evaluation. So, question?
Currently, our dialogue response time and everything looks good, but how can I know whether I have issue today or not?
So it depends on are you getting user complaints? Do you evaluate your current response times with your peers in the industry?
Average it looks good, but is there something I can go and dive in deep and find out whether I still need improvement or I'm okay at this point?
Yeah, so I mean, one way of doing that is invite some of the ADC companies to actually do a proof for you, right? Taking some of your traffic and see the user access for it, right? Because one of the challenges is, whether you can offload and reduce the cost of your business. So the proof is, does it save you dollars? If it does, makes sense. So, I mean, you'll get, latency benefits regardless of, but definitely the value is, can you save some money while doing it, right?
Other products like SiteMinder does some of these.
SiteMinder is main. So okay, yeah. Any other? Okay, so typically the way SiteMinder works is SiteMinder is an identity management system. So typically when a user comes in, SiteMinder is used in the enterprise to take a username token, for example, a SiteMinder identity token, and then provide. So they have a directory of usernames plus access, right? So they give a yes or no. So some external system requests SiteMinder whether this user is authentic and authorized or not. And those systems could be applications for authorization checks. They could be any network device that is doing an access enforcement. but the enforcement information is kept in SiteMinder. That's how typically SiteMinders, LDAP, Active Directory, all of these systems are used. So you're not bringing the, so ADCs act as an enforcement point, but not the enforcement system itself. Any other questions? All right, perfect, thanks. Hope the session was useful. There's an evaluation form. I would appreciate if you could actually fill out. Thank you.